Hello, everyone. Welcome to Secura webinar. My name is Julia Plivaka. I'm an account manager of Product Manufacturers Group at Secura, and I will be a host for this webinar. Today, we will talk about UNECE regulations on cybersecurity and software updates. And I would like to introduce our speaker for today. It's Razvan, Group Manager, Product Manufacturers at Secura. This presentation will be followed by a Q&A session, so feel free to leave your questions in the comment section and we will address them after the webinar. And first, let's start with a few words about Secura. Secura is a Dutch security company with over 20 years of experience on the market. And our approach is to link security to various standards, metrics, and certification schemes, as well to focus on people, processes, and technology. And we visualize our services as shown on this diagram, covering IT, OT, and IoT for different domains such as, for example, public, finance, technology, industrial, and product manufacturers. Razvan and I are part of Product Manufacturers Group, and some of our services include testing, evaluation, and certification in line with internationally recognized standards and regulations, for example, for IT and IoT products, medical devices, industrial products, and automotive. So now let's start with the presentation, and Razvan, please go ahead.
Sure, thank you very much, Julia, and good afternoon, everyone. Thank you for joining this webinar. Our program today will be focused on presenting a high-level overview on two recent regulations which have been published by UNECE, the United Nations Economic Commission for Europe. And in particular, we will be looking and talking about the regulation on cybersecurity called R155, 155, and the regulation on software updates called Regulation 156. So this is the agenda that we propose to you for this webinar for the next approximately 30-35 minutes. We'll start with a brief introduction on UNECE and a bit of a discussion about how does the landscape of vehicle regulation work, how does it work for a vehicle manufacturer to get their vehicles type approved in multiple countries. Then we will focus our time especially on the two regulations that are in the focus of this webinar. So that would be the cybersecurity regulation, R155, and the software updates regulation, R156. After, we'll explain very briefly what you can find within those regulations from a requirements point of view. We'll spend a bit of time explaining the expected impact, but also timeline of those regulations, and also some next steps that we envision will be relevant for the world of vehicle manufacturers, but also for the supply chain. And finally, of course, we'll dedicate a bit of time at the end for your questions and answers. So feel free to type your questions also during the webinar in the questions box in GoToWebinar, and we'll tackle them at the end. So that being said, let's get started with the first part, which is focused on UNECE generally, and a bit of background on the world of vehicle automotive regulations. So UNECE, as mentioned before, stands for the United Nations Economic Commission for Europe, and this organization, of course, is busy with quite a few things, quite a few activities. It's not only about vehicle regulations, but vehicle regulations are actually quite a large part of what UNECE is currently busy with. And that being said, of course, we do have quite a broad scope of vehicle regulations which are being drafted, maintained, and managed by UNECE, and those cover quite a few aspects. And for example, we can think about braking, general safety, emissions, lights, tires, noise, airbags, and so on. So basically, everything that would be of importance within a vehicle is one way or another regulated by UNECE. And of course, as we can see, this covers both things which are vehicle specific, such as safety or emissions, but also things which are focused on a particular system or a particular component within a vehicle, such as the airbag or the braking systems. Now, of course, UNECE is an organization which is quite global. It covers most of the continents and quite a lot of countries worldwide. So from a vehicle manufacturer perspective, it would be quite challenging if they have to reapply for approval over and over again in each of the countries that they want to address with such a type approval certification. Therefore, one thing that got introduced already quite a long time ago is the idea of mutual recognition agreements between countries which are members of UNECE. The most important of such agreements is called the 1958 agreement. The number stands for the year when the agreement was first initiated and the first countries joined this agreement. And this agreement ensures that whenever a vehicle manufacturer certifies, so does a type approval for a vehicle in one particular country which is member of this agreement, then all the other countries which are members of the same agreement would automatically recognize the vehicle type. So that being said, a vehicle manufacturer can perform the approval only in one country, member of the 1958 agreement, and then all the other countries will recognize the same type approval, so they don't have to do it over and over again. Of course, that saves a lot of time and becomes an efficient approach for vehicle manufacturers. In the picture, we can see in red the countries which are currently members of the 1958 agreement. We see pretty much the whole Europe, but also other larger areas, such as important countries in Asia, like Japan or South Korea, Australia, a few countries in Africa as well. Notably, we can see that North America is not covered by the 1958 agreement because up to this point they still preferred to make use of their own national regulations for the market access of vehicles. But as we can see, UNECE regulations are covering quite a broad part of the world at this point. So, how did we shift our focus in the last few years on cybersecurity? Because, as mentioned on the previous slide, UNECE does have quite a lot of regulations in place which are covering various aspects. And if we think about it historically, those regulations have always been drafted hand in hand with the needs of a certain moment or a certain decade. So quite a long time ago, a few decades ago, we had the first regulations on critical aspects such as safety or braking or airbags, lights, and so on. Then back in the 90s, when of course the general pollution aspects and emissions became much more important, then regulations such as the CO2, the emission regulation, became to be published by UNECE. And until recently, we didn't have regulations which are focused on, for example, cybersecurity or software update topics. And the main reason is simply the fact that until a few years ago, those were not seen yet as critical aspects of vehicles. Of course, that's due to the fact that vehicles were starting to have a set of connected interfaces and more software. However, until, let's say, around 10 years ago, it was still not something that was visible as a potential exploitable aspect of modern vehicles. Quite an important turning point happened around the middle of the 2010 decade, when it became quite clear that potential security vulnerabilities which are applicable to vehicles are not only theoretical anymore, so they're not just the subject of scientific papers or controlled area demonstrations, but they can also really apply in real life. At some point, there was a famous attack on a Jeep vehicle, which got exploited due to one potential vulnerability in the infotainment system, which got remotely exploited by a group of scientific hackers. And based on this exploit, they were able to push the car out of the road. That was one of the first clear proofs that cybersecurity is not yet just scientific anymore, it's not just theoretical anymore, but it can definitely be applied in practice. And the fact that a modern vehicle nowadays has so many possible interfaces, actually much more than it had 10 or even 5 years ago, is definitely a proof that those aspects are becoming more and more important. And one other thing that we have to keep into account is that when we talk about connected interfaces or connected software, it's not really applying to let's say, high-end cars. So it's not something that is relatively uncommon and it can really affect one certain group of people or one certain group of cars. It really could affect even basic interfaces. And nowadays, we as consumers, as people or companies who are buying and relying on vehicles, most likely we cannot really assume a situation in which our vehicles don't have at least a basic set of interfaces and a basic set of functionalities. For example, probably we would not even consider buying a vehicle which doesn't have at least support for phone connectivity, so for smart navigation, for maps, or at least a default basic set of interfaces such as USB, Bluetooth, even Wi-Fi, voice control, and so on. Those are basic functionalities. They're not that strange. They're not that new anymore. However, all of those interfaces, of course, they do come with their set of security vulnerabilities, which are already published, but constantly we have new and new vulnerabilities which are being researched for those interfaces. And one important final thing to keep into account is that as a hacker, in order to hack a car or a truck or a trailer and so on, you don't have to completely break all the architecture of that product, of that vehicle. You only need to open one door. For example, you only need to hack one interface, or you only need to exploit one vulnerability, maybe in a component that is not even that critical for the architecture. However, once you do break that one particular vulnerability, you are, let's say, inside the vehicle, virtually inside the vehicle, and from that point you can start doing much more damage and potentially impact the safety of the vehicle and the passengers of that vehicle. So that was the main reason why we put more and more focus on the aspects of cybersecurity and also software updates, of course, because modern vehicles include a large number of software images which are constantly updatable, either wireless or through wired updates. And that was pretty much the background of those two new regulations. Now, since we explained a bit about the need and why do we consider to draft and implement those two regulations, let's spend a few moments for each of them explaining the main concepts behind the regulation and what are the types of requirements, the types of processes and evidence which is being required by each of them. So let's start with the cybersecurity regulation, the so-called R155 regulation from UNECE. And starting with the scope of the regulation, of course, very important, because that will define the groups of vehicle manufacturers which are, at least in the first instance, affected by this regulation, so which will have to become compliant with the regulation. We are talking about, in the beginning, three categories of vehicles, categories M, N, and O, which are linked with vehicles used for transport of passengers, like commercial cars or buses, vehicles used for transport of goods, like trucks, for example, but also connected trailers, as long as the trailer is equipped with at least one electronic control unit, ECU. But nowadays, of course, most of modern connected trailers are equipped with at least one ECU. So most of them are expected to come in the scope of this cybersecurity regulation. So we do see that quite a big range of vehicles which are commercially produced, manufactured, and sold will be in the scope of R155. And correlating this with the set of countries which are covered by the regulation, we do see that quite a big part of the world will become in the scope of the regulation. Now, if we look at the regulation from a high level, we have a few remarks which can be seen from the beginning. First of all, the regulation is one of the few regulations of UNECE that takes the whole life cycle of the vehicle into account. So it's not linked with only one moment, for example, the production moment or the development moment. It's not linked with a certain instance in time. However, the idea and the intention of the regulation is to ensure for processes which are covering the whole life cycle of a vehicle. And by the whole life cycle, we mean all the way from the beginning, from the concept and development phases, but then also going through production, post-production, and finally removal from service. So it's the kind of regulation that wants to ensure that the vehicle is not only secure the moment when it leaves the factory, but it also stays secure throughout the time. Furthermore, one other important remark that we can see directly if we read the contents of the regulation is that we have two main parts, the so-called CSMS, Cybersecurity Management System requirements, and the vehicle type requirements. We'll discuss a bit more about each of them over the next couple of slides, but in principle, the CSMS requirements refer to the processes which are behind the development of a secure vehicle, and we'll find out more about which processes those are. And the vehicle type requirements are the requirements which aim to demonstrate that a vehicle actually follows those certified processes and is ultimately secure from its own architecture perspective. So let's spend a bit of time analyzing what kind of processes are being required by the R155 regulation, by the cybersecurity regulation. That will be covered by the CSMS part, the cybersecurity management system. One very important remark is that the cybersecurity management system part of the regulation cannot be skipped by vehicle manufacturers. It's not an optional aspect. In fact, it's very important and mandatory to be the first part that they achieve. Without a compliant and certified CSMS, they are not allowed to go ahead and apply for type approval for their vehicle types. Therefore, the CSMS becomes the first block, the first brick in their journey towards R155 compliance. And in order to get your CSMS certified, you need to have, of course, all your processes up and running, but not only up and running in the sense of being documented, but also at least implemented for a certain moment of time, such that the manufacturer can demonstrate that the process is already alive and there's a bit of evidence to support the fact that the process is active. If the manufacturers end up with a compliant set of processes, then they will receive a so-called CSMS certificate, which will become valid for 3 years unless there are changes to the processes. But over the duration of the certificate, then they are free to apply for as many type approval certifications as they wish, as long as the vehicles are being developed in line with a certified CSMS. One remark, even though it's slightly out of scope for this webinar, is that the CSMS assessment by concept goes very well hand in hand with the requirements of the ISO 2144 standard, which is a standard defined more or less in the same timeline with the regulation 155, and actually quite a big overlap also in the people who drafted the standard. And in principle, if vehicle manufacturers and suppliers want a bit more practical approach on how to address the process requirements of R155, for sure they can turn their attention towards ISO 2144, because the requirements of those two publications go very well hand in hand. Now, if we take a look at the main areas of R155, we see 4 types of processes, which are the security management processes, then the processes linked with risk management, then the ones linked with incident and vulnerabilities monitoring and response, and finally dependencies and management of suppliers. So what we'll do over the next couple of slides is give a few notes, high level, for each of those types of processes, starting with security management. When we talk about security management, we have in mind procedures which are linked with governance, for example, across the vehicle manufacturer organization. So who is in charge of what? There needs to be clear accountability. People need to be very well aware of what they have to perform, of the planning of the activities, of the dependencies, and they should all work towards the same goal. There needs to be a demonstrable awareness all the way to the top management. It doesn't necessarily mean all the way to the C-level, so the sort of top level of the organization, but there needs to be someone who is ultimately responsible for the definition and implementation of the processes and evidence in the scope of the regulation. One final thing is that also cybersecurity competences and cybersecurity training across the organization would fall into this group of processes as well. So people who are in charge of doing one particular task need to have the certain skills or a certain knowledge or even certifications required in order to perform in a correct and complete way that specific task. Moving further, we end up with a second group of processes which are linked with risk management. That's actually one pretty large part of the regulation, and in fact, arguably is the part of the regulation which might take the most time in implementing for vehicle manufacturers. So those are the types of processes that include several steps linked with the whole range of activities around risk assessment. It starts with the step of identifying critical components in the vehicle. Then it starts with identifying security threats linked to those critical components, identifying attack paths linked with those threats, rating aspects such as impact and feasibility of those attacks, and finally, based on those two inputs, calculating the level of risk. By the way, this will go very well hand in hand with the requirements of ISO 2144, which defines its own methodology for performing risk assessment in automotive. Once the risks are rated, then of course the OEM will be in front of the challenge on whether or not they can be accepted or they need mitigation. If the risks are too high, then they will have to be mitigated based on a baseline minimal set of mitigations defined in the regulation as well, in the so-called Annex 5 of the regulation. And once the risk has reached a certain low level, then the manufacturer can decide to accept the residual risk because it is low enough. One further set of procedures, and this is particularly important over the phases of production and post-production of the vehicle, is being able to monitor, detect, and react to incidents and new security vulnerabilities. Typically, when the vehicle is new, if it did pass the type approval, it means that at that point in time it's free from security flaws, security weaknesses. However, only a couple of months later, for example, there could be a new vulnerability being published, and the vehicle could be the target of that vulnerability. Therefore, the vehicle manufacturer needs to have in place a process based on which they continuously monitor for potential security incidents, both on the vehicle but also on the back end or services which are linked to the vehicle. but also monitor for new potential vulnerabilities which are being published and which might be impacting their vehicle types. If such an incident or vulnerability is being detected, then they need to have a way to react and adapt their architectures such that the vulnerability is being mitigated and cannot affect the vehicle type. Finally, in our walk through the processes, we want to visit the topic of the supply chain interaction. Very interesting, and for sure we could talk much more about it. But in principle, the regulation does apply to vehicle manufacturers, so not to the supply chain. However, the vehicle manufacturers most likely will need to interact quite a lot and work together quite a lot with the supply chain and make sure that a certain set of evidence is being provided by the suppliers towards the OEMs for the purpose of compliance and approval. When we talk about the vehicle type assessment, the main question that we have to keep in mind is once we have the processes approved and certified, is the architecture, is the vehicle type developed in such a way that it follows the processes? So, for example, we did talk about the risk assessment process. The type of evidence that you would need for vehicle type assessment is, for example, all the risk assessment results, all the TARA results, or all the testing results, or all the evidences of how you apply incident management for vehicle types. As well as those technical elements are being covered, then a vehicle type can be sent for certification and ultimately type approved. That was at a very high level a bit about the R155 regulation. Now let's move our attention towards regulation 156, the software updates regulation. And the good part is that once we'll go through the next few slides, we'll notice that there are quite a few similarities, at least in the structure and in the intention of the regulation. First, to start with the scope, we do see a bit of an overlap here, but also a bit of a difference. The scope of the regulation does cover the three types of categories which are also in the scope of R155, so cars, trucks, buses, and trailers, but also extends the scope to agricultural vehicles and also special purpose vehicles. Therefore, the scope for regulation 156 is slightly larger than the scope which we saw in R155. In terms of the overview, we see a very good similarity because also R155 defines a process part. This time we are talking about an SUMS, Software Updates Management System. And again, it defines the vehicle type requirements. The SUMS will be linked on the processes and procedures behind the vehicle type architecture. And then the vehicle type requirements will be the more technical parts in which the OEM will have to demonstrate that the processes are applied in practice for the software updates architecture. One important remark that I would like to highlight is that the R156 regulation is not a software updates security regulation. It's just a software updates architecture regulation. So therefore, security is one part of it. In fact, there's a whole chapter about cybersecurity, but there are also other elements, as we're going to see over the next slides. Finally, while for R155, we did provide the mapping and pointer towards ISO 2144. In case of R156, ISO is currently preparing a standard called ISO 24089, which is currently in the final draft format. It's also open for comments. But this standard is envisioned as being the guidance, the support standard for vehicle manufacturers in order to make their mission easier to comply with R156. So the main areas of the processes, again, we can group them into four categories. Dealing and managing with software versions for multiple software images, checking and ensuring software compatibility and interdependencies. Then we have the cybersecurity part, which is one part of the regulation for the software updates infrastructure. And finally, the part about software guidance and information provided to the users. So in the same style, we'll spend a couple of moments for each of those categories. When we talk about keeping track of software versions, basically what is needed is that the vehicle manufacturer, the OEM, has in place a way to keep track of different versions of software, both old as well as updated software versions, including, of course, also a summary of changes, a link between those software versions and particular ECUs, particular vehicles in the field, and also a link between the software versions and particular regulations. As long as this is being kept and managed in an efficient manner, it doesn't matter so far how you do it. It can be based on the idea of the RX Twin, which is introduced by the regulation for keeping track of software versions, but it could also be done in a different way by, for example, making use of a large database. Right now, it doesn't matter. There are multiple options in place, as long as the manufacturer can demonstrate a good management, a good overview of software versions. Of course, whenever we are talking about a new software which is being developed and sent to the vehicle, one important process that needs to be ensured is verifying that the software is compatible with both the previous software but also the hardware of the vehicle, and what kind of impact, what kind of interdependencies will the software update have on the previous components, but also on various other software images which are being installed and run on a vehicle. Those kind of things need to be taken into account and well considered by the OEM for each software version. We arrive at the security part, which, as mentioned before, is just one chapter of the regulation, but of course one important chapter. Typically, it goes very well hand in hand with the R155 regulation. The main difference is that while R155 focuses strictly on the cybersecurity of the vehicle, then R156 focuses on the cybersecurity of the software updates infrastructure. So pretty much the path implemented from the backend all the way to the vehicle, based on which software updates are being sent either wireless or otherwise by wired means. So that needs to be secured such that updates cannot be intercepted or modified. Finally, of course, software updates need to have sufficient guidance, sufficient instructions for the users, such that the users are fully aware of what they are asked to install over their vehicle, and also they can decide whether or not they want to install that update on a vehicle. Also, there needs to be a clear indication on whether or not the update has been successfully installed, and what kind of steps the users need to take in order to ensure that a safe state is being kept as long as the software update keeps running or keeps downloading. For the R155, we did say that in terms of vehicle type requirements, it's mostly a demonstration that the processes are applied well in practice. And in fact, for R156, we have the same situation. So we did spend the last couple of moments explaining about the processes. From a vehicle type perspective, what needs to be ensured is that the actual architecture, which is being proposed by the manufacturer, covers and is designed in line with those certified processes. And that needs to take into account aspects such as software versioning management, protection of the software update contents in terms of integrity and authenticity. So basically, the cybersecurity part of the software architecture, the safety of updates, also of over-the-air updates, including the safe state on the vehicle itself, and finally, the way in which user information, user guidance is being provided before the users can decide to go ahead and install the particular update package. Now, after we spent a bit of time talking about the high-level contents of those two regulations, let's focus the last part of this webinar sharing some thoughts about the next steps and about also the estimated impact, the estimated pain points that manufacturers can encounter over the next months. First of all, we do base those conclusions on some experience with real customers that we had over the last months or also over the last years. And one important conclusion that actually we did drew after we worked with a few customers is that when we talk about the impact or how different OEMs are being affected by the regulation, what they should be aware of, it's somehow very challenging to find too many common points. And that's interesting, but also it's true because different OEMs will always work in slightly different ways. And then we try to understand how does that happen? Based on what do they differentiate themselves and how come they are affected in a different way? We did find a couple of pointers. For example, the amount of awareness, the amount of understanding of the regulation does play, of course, a very important point. The more you know about those requirements, the more you understand them, also preferably in time, so before the actual deadline for the regulation, the better, because then you can react and you can start identifying your gaps in processes, and you can start, of course, working towards closing those gaps. The size and complexity of the organization and the processes is very important, sometimes also quite critical. Most of the times, OEMs will choose to adapt their existing processes in order to incorporate cybersecurity, and that, of course, does make sense because it sounds like the most efficient way to address R155 and R156. However, of course, depending on how complex and how distributed those previous processes are, it might be easier or harder to directly integrate all the requirements of the two new regulations. Of course, also it depends very much on the complexity of the organization for the OEM. If the organization is more compact and pretty much working on a single set of processes, then probably it will be a bit easier than compared with a situation when we have an organization distributed across multiple countries, maybe even multiple continents, who work on slightly different variations of processes, like for example, 2 different ways of doing risk assessment, 2 different ways of doing testing, and so on. But of course, that depends on a case-by-case basis. The dependency with the supply chain is something very important, and we will also highlight that on one of the next slides as a typical pain point, because what we do notice is that vehicle manufacturers are typically large integrators of components and software. They don't manufacture themselves too much, but they acquire all of those ECUs, all of those components, and they assemble them together into the final vehicle. And the regulation does ask the vehicle manufacturer to be in control of the risks from the supply chain. Therefore, there's quite a lot of information that needs to be handled between the manufacturers and the suppliers, and all of those exchanges, even if they are simple contractual agreements or more concrete evidence, they will take time, and they will take probably multiple rounds of negotiations between the OEMs and the supply chain. So that needs to be taken into account for sure. Finally, the experience that the OEM has in terms of cybersecurity, also in terms of the regulation, of course, but also in terms of cybersecurity in general will matter. Some organizations do have extensive teams that are experienced in cybersecurity, and then they can take on board tasks of, for example, doing cybersecurity testing or cybersecurity risk assessment by themselves. Some others have slightly smaller teams and prefer to subcontract this part. Both options are, of course, fine, but the OEMs need to be aware and need to be convinced that they remain in control of all the progress. When we talk about pain points, maybe there are a few more, but we wanted to highlight 3 of them. We do see that the process of obtaining the documentation and required agreements, required evidence from the supply chain could take quite some time. More important is the fact that it's not only something that you will do one time as a vehicle manufacturer, but at moment 0, so in the beginning, you might have a set of evidence to collect, a set of contractual agreements, but also throughout time with various updates to the components, with various new vulnerabilities, new incidents. Then there's extra information that needs to be continuously monitored, continuously collected, continuously reviewed. So that will probably lead to a considerable effort and quite a lot of back and forth communication between the OEM and the supply chain. What we typically see is that the part of finalizing the risk assessment, the TARA results, to use a more automotive specific terminology, but also the testing part does also take quite a bit of time. Of course, depends very much on the complexity of the vehicle, but in a modern vehicle, we are talking about dozens, maybe even hundreds of ECUs that will have to be analyzed from a TARA perspective and also tested. And that's only on the vehicle part, but of course, we have to remember that there's also a certain amount of backend involved in the scope of regulation, as long as it communicates with the vehicle. So that needs to be taken into account. And finally, as also mentioned on the previous slide, integrating and incorporating cybersecurity into existing, for example, old safety processes is a path that most manufacturers will probably consider, at least, but it's something that will, from our experience, still come with a set of issues and needs to be carefully handled. Finally, as a set of next steps, the 2 regulations, the R155 and the R156, are currently alive. They are into force as of the beginning of last year, 2021. From July this year, the R155 regulation will become mandatory for new vehicle types in Europe, in the European Union. In Japan, for example, the regulation is already required from last year for new vehicle types. It was one of the first countries that adopted officially the regulation. When we talk about R156, it's still waiting, it's still pending a mandatory moment. The intention was initially to have them both start at the same time, but UNECE wanted to give a bit of a head start to cybersecurity and still pause a bit the R156 regulation. However, it's quite close to a moment when it's going to become mandatory. And besides the 2 regulations, there are also official interpretation documents available, which are aimed to ensure a bit of a common understanding, a bit of a common language for both vehicle manufacturers, but also approval authorities and technical services who are in charge of performing the audits and type approval. So that being said, I hope you enjoyed the contents of this webinar. What I could finally say is that we definitely have interesting times ahead. We are getting very close to the deadline in the European Union, at least for R155, just a few months to go. And we at Secura, we tried over the last couple of years to be prepared for this moment. We joined the both of R155 and R156 quite early during the drafting period. Over the time, we have defined our service offering for those two regulations, and we have also obtained the status of technical service for 2 approval authorities in the Netherlands and in Cyprus. We can support companies, both manufacturers as well as suppliers, with quite a cluster of services, starting with trainings, with workshops to understand the regulation, and then going all the way to gap analysis, consultancy support, and also official R155 and R156 audits and certification. So feel free to reach out to us for more information. And just before we open the round of questions for this session, I would like to point your attention to 2 white papers that we recently drafted. So for sure, whenever you get a moment, please check our website, and you'll be able to download for free those white papers that provide a bit more information about especially the R155 regulation, which is coming very close to a deadline this year. And finally, this webinar is the first in a series of upcoming events linked with the world of automotive cybersecurity. We do have 2 more webinars which will go a bit more in depth into what R155 will mean both for vehicle manufacturers as well as for the vehicle suppliers. We have also a webinar which will be dedicated a bit more on how to perform risk assessment on automotive, especially in line with the regulation. And finally, we have a 2-day course, a 2-day training, which will go deeper into the contents, requirements, and expectations of ISO 21434. So feel free to check those events and register to the ones that you find interesting. So that being said, thank you very much for your attention. And at this point, I'll be happy to take some questions from the audience.
Yes, thank you, Razvan. We do have a few questions. So I will start with the first one. And the question is, does this regulation only affect OEMs or also suppliers, and up to which tier?
Okay, thank you for the question. Formally speaking, the regulation affects only OEMs. It's clearly written in the regulation that it is defined for OEM classes, for OEM manufacturers, and not for suppliers. However, there is one requirement that asks the OEMs to ensure that their supply chain is sufficiently cyber secure. And that sounds like an easy requirement. However, it comes with a pretty massive weight, because it simply means more indirectly that OEMs will have to go back to the suppliers and ask for a certain set of evidence. Therefore, the suppliers will be dragged into this whole range of activities to ensure compliance. That being said, the suppliers will only have a subset of the requirements to address from that perspective. So not the whole regulation, but only a few requirements. So their mission is slightly easier, to put it this way, than for the OEM. And talking about tiers, that's also a good question. For now, it's a bit depending on the approval authority. The general intention is to make the regulation mandatory for tier 1, so for direct suppliers of OEMs, at least in the first couple of years. And most likely, once this process will be kicked off, and most OEMs will become comfortable with managing at least their tier 1 suppliers, then for sure the expectations will go deeper to also tier 2 or tier 3 suppliers. But at least for now, the biggest worry, the biggest concern that the manufacturers will have will be in managing their tier 1 suppliers.
Okay, thank you. And the follow-up question is, does this regulation affect the cyber infrastructure of the manufacturer, or only what is present in the vehicle?
Mm-hmm. It does affect both. So the scope of the regulation, the way in which vehicle type is defined in this regulation includes, of course, the vehicle itself, but also critical elements of the backend of the infrastructure, which are used to communicate or store critical vehicle data. So, for example, when we talk about the software updates infrastructure, which will directly connect the vehicle to the backend, that will be in scope. When we talk about the systems used to store vehicle architecture designs or results of risk assessments, results of testing, those will also be in scope. But of course, not all the backend will be in scope. Parts of the backend which are totally used for non-vehicle related parts, like your let's say mail system or financial systems and so on, those will not be in scope. But only the parts of the backend which are linked with the vehicle or storing or processing vehicle data.
Okay, thank you. And we have one more question. Where do you expect the largest effort will be for the manufacturers in ensuring the compliance to these regulations?
Right. This is a very good question. That of course we actually heard a few times, and there isn't a straightforward answer, unfortunately. It depends very much on the situation of the manufacturer. However, what I could do is give maybe a couple of examples to clarify a bit the topic. If the manufacturer is totally new to the idea of cybersecurity, so far they didn't consider cybersecurity too much because of course it wasn't mandatory, so that could very well be the case, and now all of a sudden they have to build up cybersecurity, then I would expect that the biggest effort will be simply in defining those procedures. So making sure that they have a way to do secure development, they have a way to do secure production, secure versioning management, and risk assessment testing, and all of the others. So that will be quite a bit of effort simply because they are brand new and there's no previous experience. So that being said, if you're totally new as a manufacturer to cybersecurity, I would expect the biggest amount of effort, at least in the first instance, will go in that direction. Luckily, we have standards like ISO 2144, as mentioned during the webinar, which could definitely help manufacturers understand a bit better this topic, especially if they are very new. If manufacturers already have some procedures from the past, when they have already considered cybersecurity, that's a very good head start, to put it this way, because they are a bit prepared already. And in that case, the biggest effort will be simply in applying those procedures for a vehicle type and simply gathering all the amount of evidence. And yes, we are talking about quite a bit of evidence because we need to have in place all the thorough results, all the test results when they want to apply for the vehicle type approval, but also all the information collected from the supply chain. So all those contractual agreements, all those sets of inputs from the suppliers will have to be collected, obtained, and managed, reviewed. And that will take, again, quite a considerable amount of time if the communication between the manufacturers and the suppliers is not optimal, to put it this way. So I hope that brings a bit of an explanation, but ultimately it will always depend on a case-by-case basis, depending on how mature the OEM is already in terms of cybersecurity.
Yes, thank you, Razvan. That were all the questions for today. And thank you everyone for joining this webinar. As Razvan mentioned, we have more webinars coming up with more in-depth content. And yeah, thank you everyone for joining. And we would appreciate if you could take a few moments to fill our survey, which will pop up just immediately after this webinar is finished. So thank you everyone, and we hope to see you next time.
Yeah, thank you very much, Julia. Thank you very much, everyone. Have a nice day. Bye-bye.
Bye.